a lot of places. Just right now with me moving things around and still building things, asking me questions won't get you really clear answers because it's all still happening. It's all still fluid. And yeah, I would have waited for Discovery Day, but that's 2 weeks away and my brain was just on fire, so I decided I needed a new organizational system because having 3 different classes is getting stressful. So, today is 225. On that note of me having to reset some organization, if you are feeling the pressure of the end of the quarter, organization can normally help. So please make sure that when you enter classrooms, you are organized for that class, which in my room should look like normally at least a blue sheet out, right? So for today, you just need today's blue sheet. We might get to checking some more. We might get to checking some homework problems. When you start to just trip on your words, it's better to just completely fall over and then pick yourself back up and start again. What?
It's 226 and not 226.
Oh, I pulled out the wrong. You can keep those.
I already on it. Too late now.
You can keep those. Go ahead and put those in your binder. I'm really on my evenings today. What, you're not ready for 226? You don't want to just skip 225?
I can.
No, that would be a bad idea.
I'm okay with
It's
that.
actually a pretty useful lesson. Here's 225. You did get 5 sweet. You are on your own. Make sure you get out some graph paper back here. Did you just grab 6 or 5? Right, so now you have 5 and 6, and you guys both need graph paper out. So, I need your attention because I don't want this to be confusing. Is there another one? Oh yeah, malarkey. What are you trying to do? 222. It's the last one. So yeah, what was last night's typo, Zach? Oh yeah. In 83 from last night's homework, if you care to change this real quick, and again, if you think things look weird, check the ebook. Typos happen. On 83, it is not 38, it's 3/8. So you can normally guess it's some sort of formatting issue that has happened. If the number doesn't make sense, try to make sense of it. Something of the time is probably going to be a percent or a fraction, right? Like a portion of the time. So on 83, that's 3/8 of the time. And to get our final grades in, everybody, either on your plan book, your notes, somewhere, write this down. I got to reset this. I'm even going to make a new slide for this. That's how important it is. If you are not very organized, you may want to, write this in your plan book. Would probably be advisable. 222 makes me want to dance. I can dance if I want to. Can I leave my friends behind? 222 through 224 due tomorrow. Really Friday. So you should have it done by tomorrow, right? Because it's Tuesday's homework. You should have it done by 2 days later. So you should be ready to turn it in tomorrow. But if you get it to me by Friday, we'll be good. Okay, that's our last homework collection for quarter 1. That doesn't belong there. It's so low, that's the problem. So this is our last homework for quarter 1. Yeah, now that doesn't mean stop doing your homework, because we will keep collecting on the same cycle we've been on. The grades just changed to quarter 2. Is anyone confused how that works? This is our grade cutoff, but grades will still go in math because today is just the last day of quarter 1, like things happening. Those grades will still have to go into math. They will be quarter 2, yes. So even though today could count as quarter 1, I'm batching my homeworks 3 at a time normally because it's easy for me to check. how many quarters? Listen to the question.
Hold on, sorry.
How many tenths are there? All right. Yeah, I missed a parenthesis here. So we are ready to dive into 225. And this is not on your blue sheet, but the next question is. So please keep out today's blue sheet. We have two really important questions on there. So we just want to chat about this real quick. So you might write some stuff on your graph paper. You might just engage your brain with me. If we have 200 people entering a competition, a friend of mine actually just entered a bodybuilding competition, did quite well. Yeah, she is scary built. She's super muscular, no joke. And a fourth of them are chosen for the final round. Okay, so I would write down somewhere, like let's go ahead and write this down. I'm not gonna make you read a lot, but I would write 200 total. A fourth get to the final round. So if we go to figure out who makes it to the final round, how do we show that math? Well, ooh, yeah, but if we want to do it actually how they said it, a fourth of the contestants. You're right, we could do 200 divided by 4. Or if we want to show exactly what they said, and if we want to, because today is multiplying with fractions or multiplication of portions, we would write 1/4 times 200. Now here's the trick. Our life is easier if everything is fractions. So even though 200 doesn't need to be a fraction, we can make it into a fraction. And then our math, I don't like using this word, but yeah, this is easier than addition of fractions because we don't have to care about common denominators. We go straight through and we get 200 over 4, which is exactly what Bella told us to do. 200 divided by 4, which is 50. So 50 contestants made it to the final. Now, why do we care about multiplying fractions, and why do we say fractions with other fractions are better? For example, such as Cameron, or actually I was at cross country last night, saw a lot of people run really fast. Cameron sprinted 2/3 of the quarter-mile track. How far did he actually sprint? Well, 2/3 of a quarter mile, right, but how far actually? Well, that math, all we would have to do is 2/3. What does of tell us to do? Multiply the quarter mile. He sprinted 2/12, yeah, or 1/6. So multiplying fractions, I will risk it and say it, is easier than what we've been doing. So I want you guys to dive into this. Now we're taking a step back, right? Go back to yesterday, not multiplying with fractions, because that's what we will be doing today. Go ahead and solve part 1 of Cecil's routine, and then I put part 2 on the next page. All right, go ahead. This is on your blue sheet. Should be. No, did I look at the wrong blue sheet? Maybe that's why I gave you guys the wrong blue sheet, because I looked at the wrong one. Yeah. Sir, were you looking at the back? You're looking at the back. Yeah. On the front of your blue sheet, this is on the front of your blue sheet. So you don't need to put this in your graph paper. This is on the front of your blue sheet. Let me just separate. Now, this is where I start to flex off of what CPM says. Sometimes when they say we're going to draw a diagram, I don't require that. Never mind. So normally if you just try a little bit longer on your own. Okay, you're already done with that. So, following PEMDAS, this is where a lot of people say we have to do parentheses first. Except there's nothing to do. Right? be aware these parentheses are indicating multiplication, multiplication, negative. There's nothing to do in the parentheses. So as I walked around, I saw most of us, this is the best way to do it. Now you could write out here what things became, but if we drop vertically, this helps our brain, guys, because then our brain can see the 3 times 2 became 6. What would go here? 9. And then the negative 5 is still negative, and the positive 4 is still positive. Don't change things that don't need change right now. But now, what would we do? Hold on, we got to use some cards today. Is this the right class? Yeah, it is the right class. Except is Savannah here? Yeah. Oh, you're right in front. Savannah, what would we do now?
I personally started by adding 6 plus 9 to get 15, and then adding negative 5 plus 4, and then adding the result of those two together.
Ooh, I like it. Now just because my brain is constantly a comic book, it seems like, I would sort good guys, bad guys. Right? So I would literally use what property tells us we can move things? Nah, starts with a C. The commutative property. Now you don't have to actually write this, you could just do it mentally. Right? So I can sort and move positive with positive, negative on its own. 6 plus 9 is 15, plus 4 more is 19, and the negative 5. Now what Savannah said would absolutely work. This is just how my brain thinks, is sort the positives and the negatives, and then fight. All right, who wins here? Good guys, by how much? 14. Anybody have any questions on how we got that? Now that was only part 1. Go ahead and do part 2. The sequel. He does take a battle. That is very important. This, very good question from Araya. If we do parentheses first here, what do we notice? Araya, why did you ask that? Well, yeah, but what do we see if we do parentheses first here?
Well, first I saw the 1 plus the negative 1. And then I also saw 5 plus negative 2.
Yeah, so if we drew a diagram, give me your eyes for just a second, because I'm not going to make you draw a diagram, and I think you'll appreciate why. 5 plus 3 plus 4 moves of 1 and negative 1. Guys, that would look 5 plus 3, forward 1, backwards 1, forward 1, backwards 1, forward 1, backwards 1, forward 1, backwards 1. Like, they're going nowhere, right? If I take a step forwards and I take a step backwards and I take a step forwards and I take a step backwards. Like, that's what's happening right here. A forward step and then a backward step. So Araya said, well, if we do the if we do the parentheses first, this is really 0. That's a movement that gets him nowhere. So if we do parentheses first, sorry, go ahead and keep working on your own. So if the only thing we did was parentheses first, that's what it should look like. That was the only thing we did first. And then positive 1, negative 1 makes 0. The 5 and the negative 2 makes 3. Then I'll keep following PEMDAS and multiply. Remember, 0 times anything is 0. This is a good problem to warm up our brain and just do some of that quote-unquote simple math, right? Just adding up numbers. Not trying too hard. Now, we could sort good guys, bad guys right now, or do a little bit of grouping and then sort, because what do we have here? We really have here we can go ahead and put these bad guys together, but put them out here. Yeah, -8. So I know I'm kind of moving things around awkwardly. But then over here, oh, wait a minute. If we didn't put this out here, this is 8. And this is -8. What do we call it when we have a positive number and its opposite, Araya?
Well, they cancel each other out.
Oh, yeah, but Lily, what's that called? You would bring it up. Do you remember 2 words?
Inverse operation.
Ooh, yes, kind of, but not quite. Yes, addition and subtraction are inverse operations, but there's a word before inverse. They're additive inverses, right? 8 and -8 are additive inverses. They end up making 0, but we want to try to remember that vocab. They're additive inverses. 0 plus 10? This entire giant segment of moves only ended up getting him 10 feet across. Any questions on this? He's a performer. It's not about how far you go, it's about how good it looks. All right, on your graph paper, this is where you might want your ruler and anyone sketching. You got to come back with me because now we got a lot of work to do. You want to create some rectangles because we are going to save the earth one piece of paper at a time. So instead of me handing out a resource page, which is what is covered up like a government document right here, we're going to draw some rectangles on our graph paper. So your choice, 2 by 4 is pretty small. I would go at least 4 by 8. And it will make your life easy if you make the width twice the height, and if it's an even number. So I have some people that are like, can I go 5 by 10? Yeah, but it's not going to be quite as easy. My advice is do 4 by 8. So this is where if you have a ruler, you can make these pretty straight. Make your rulers nice and, or you make your rectangles nice and straight.
Square.
You calling me a square? Who you calling? Now, for as many things as we do in math that, like, and actually not in this classroom, but I mean, like, in math in general, we're like, why are we doing this? It's just some lame thing our teacher had us do. By the way, draw like 4 of these. Sorry if I didn't clarify. I have 4 up here for that reason. No, you don't have to label them 4 by 8, because all we're going to do is cut them apart. But for what I was saying, of like all the things that your teachers maybe in the past are like, this is not purposeful, this really is. This helps us visualize what fraction multiplication actually is doing. So that you don't just memorize a process. We want you to actually understand what's happening. And Eric's shirt just really messed me up for a minute. It says stay weird, but it's upside down and backwards. I literally had to say that out loud because it just like broke my brain for a moment. And you're just drawing rectangles. So why are we drawing rectangles, you might be wondering? Because Garden Road Middle School is planning a field trip. Now, here's the thing. We don't quite know how many students are at Garden Road. But they've hired us to help them with math, and they're paying us the big bucks. So, no, they do things differently around there. They have RFID chips that just get scanned when they come to school. It's weird. So, half of the students signed up to go on the field trip. So we want to, on one of our rectangles, show that half of the students have signed up. Well, we should be pretty good at figuring out what half of our rectangle would look like. Let's just cut it across. So cut your rectangle across the middle. We will shade it and say they're going. Right? So give that a label out here. Going. Or attending. Or yes. Or permission slip. Or I don't know, I could keep talking while you shade. And shading, by the way, guys, I really like what they showed here. Just like some diagonal lines. You don't need to completely shade in the space, and that also ends up like rubbing on your hand, right? If we shade in like crazy, just like draw some lines. Yeah, it's perfect. Now you'll have to then flip the other direction on the other one we do, but it's all right. You're allowed to be different. Never stop being you. Now wait a minute. We have an issue.
There's a bomb.
There's not. Only 3/4 of the students planning to attend brought their permission slips. So try to split up your rectangle to show that, and the next question we want to answer is, well, how many or like how much of the school does Mrs. Cavalucci now have to contact to get their permission slip? And this is a great time for me to bring up, if you have yet to turn in your Phoenix handbook sheet, no joke, you need to, or else like you can't go to school here. So if you have yet to turn in this permission slip, it needs to be a high priority. Nobody else in this class is my advisor. Let me punch this where you can put it in your binder. What?
Should I just give them to Velo?
Yes, or the office.
Okay.
If you have a moment to slip into the office, so put this in like your binder wherever you'll see it tonight. Just get that signed by your parents and bring it back. All right, so 3/4. How can I show 3/4 of this rectangle? Anyone have an idea for me? Oh yeah, hey Luz.
3/4.
Yeah.
Split the rectangle in 4 pieces and then shade it 3 pieces.
So split it. Do I split it this way again?
Split it in the middle.
Split it in the middle, and then there, and there. I think I know what you're doing, but I'm gonna split all of the fourths. Now, Luz, maybe, I think you might be thinking we could just do like this. Is that what you're thinking? Can I check what you did?
Oh no, I mean like that, and then like
Now I like what you're thinking, but so this is why we gotta clarify what we're doing. This, if I only draw a line here, that has split my school into 4 pieces, right? What we were told is 3/4 of the people going on the trip. So we need to split these people into 4 pieces. So that's why we actually need to split vertically to get it into 4 pieces. Because it's 3/4 of the people going. So then these 3, notice how if I go the other direction with my lines, I can double shade more easily. Those brought their permission slip, which actually I probably should have done in green. These guys brought their permission slip. How much of the school does the secretary need to contact? Zach?
1/12.
Ooh, not 1/12. How many pieces did we now break our box up into?
1/8.
1/8, and we can figure that out by doing 3/4 of the initial 1/2 makes 3/8 brought it in. But really, if we look at who didn't bring it in, 1/4, this section right here, this is who Mrs. Cavalucci is going to have to contact, right? They did not bring their permission slip, so that's 1/4 of 1/2 makes 1/8. So if we use the fractions that they gave us in the problem, 1/2 and 3/4, we'll get 3/8 are ready to go, right? 3/8 of the school is good to go on the trip. Everyone good? 'Cause we're doing another one. Does this make sense how we're splitting up the rectangle, Zach? Are you just stretching? All right, let's check if we have all the information here. Ooh. Now, if the total school population, they now tell us, we got that attendance sheet, right? We begged and said, please. That works really well. If the school population was 120, what do we do with that number? And I'm actually going to go back a couple steps. So this is our nice visual that we have, right? If the school population is 120, how do we work with that? Actually, I want to use some cards to hear from some people that we haven't, but it would help if I have the cards. Nikki, what do I do with that 120?
You split it in half first off.
Ooh.
Find out who's going.
So she said 120, we can either split it in half or multiply by 2, right? But either way, it's the same thing. So 60, right? So 60 plan on going. So there's 60 in that region. Now, Zach, your card is up. What could I do next?
Divide it into 4.
Yeah. What's a fourth of 60? Or I can do 3/4. So 60 divided by 4. Anyone know that off the top of your head?
That would be 25.
Close. 15, right? Cut it in half again.
Oh.
So there are 15 here, 15 there, 15 there. So 15 kids are in this region of they want to go, but they don't have their permission slip signed.
I knew.
Go to the office, call your mom, get your slip signed. Now wait a minute. The additional challenge, I don't know if I put this, well actually I don't think I have this on your paper at all. The additional challenge tells us, what if the school is 125 students or 250 students? Like, and we go back to do this math with those, like one of those numbers. Mirabelle, do you have any thoughts on what if the school was 125 students? Why did they call that additional challenge? Yeah, think about the math we did up here with 120. It doesn't evenly get split apart. So if we look at half the school and we're working with a school of 125 kids, we're not going to cut a kid in half, right?
I want to read
No, only. What's the movie with the pokey Matilda? Maybe it's too old for you guys. Yeah, with the pokies, right? The thing, yes. So maybe that principle would like cut a kid. We're not doing that. So round, right? This is where rounding would come in. So like 125 split in half, round it. Put one kid somewhere and then not like take that half, put it with the other. Realistic situations, we gotta have realistic answers. What? All right. In your shaded rectangles, show this problem. In your rectangles on your paper, show this shading. So, like one of the new rectangles. New problem, new rectangles. Oh yeah, that was weird. This is not on your blue sheet. I don't think. Yeah, the next problem. So Howie has 5/8 of his pizza left over. Howie and I are best bros. Howie has 5/8 of that pizza left over. He then decides he's taking half of that.
Half of the remaining, right?
I'm just letting you guys have time to work. Sometimes I literally just sit down at a student desk. You don't need me. You can read. You can Excel. Sorry, that's why I stopped in the middle of that sentence. So this is tricky because what we just did, the temptation here, especially with the problem that we just did, will be to take your rectangle and make it into eighths like this. We cannot do that here because when we split these area models, each thing told to us has to have its own direction. So when we go to split into eighths here to start, this is why I had you make 4x8 rectangles. We have to split literally, and I know pizzas don't get cut like this unless it's a really awkward pizza.
It's like that little Caesar's deep dish.
Yeah, we have to split the pizza like that, and then shave 5 of them. Five-eighths of that pizza left over. Now today for work, and if you
Yeah, he ate 5/8 and he's keeping half of the
And then the
leftovers.
next morning, he ate half of the.
hey, I've taught this lesson before. 5/8 should be shaded if we're trying to show what is left, and I want to show what's left, right? Because it still exists. So this is gone. There's probably some grease on the box from pizza that used to exist. 5/8 are left. He, for work, decides quit using your pencil as a weapon. He takes half of it to work. This is why we drew all of these vertically, because now we go the other direction, and he's going to take half of it to work. So if he had 5/8 left over, and then decided we're going to take half of it, that's a half of 5/8. That multiplies out to 5/16. Because now each of these pieces is a 16th. Donato's probably. I mean, Donato's got square slices. Although their slices aren't equal portions.
Wait, really? I love Donato.
What do you mean? They cut rectangle slices, but then the corners and stuff are smaller. They're not equal. Although, I think we could argue no pizza place has equal size slices.
Domino's, they like try to cut it down the middle.
Right.
They're not like measuring like.
Alright. Are we all clear and happy and okay on the fact that when one fraction is given to us, we have to divide our box the same direction? And then when a different piece of data or fraction or portion is given to us, we go the other way. Are we good with that? Okay. Now, help Joe plant this garden. So I just want no talking, so we just read, it's on your blue sheet. But read, circle, highlight, underline, whatever you need to do. We're drawing this on our graph paper, but this is on your blue sheet so you can read it, because I would underline things.
Oh, this is Joe. Is that Joe?
Joe Dominguez. He does. I like his mustache.
Oh, Mario.
Old. He's in the stories.
What?
Wait, where's his eye?
He's just trying to
Oh shoot,
He has little Mario eyes.
He is Mario.
Us not talking didn't work. Ooh, a third. Dum, dum, dum. A third. Now you could draw a different rectangle for him if you want to. If you don't want to divide thirds with the rectangle that we have. Set up a new Spotify account for
we saw it yesterday.
So you made us perfect.
DJ on camping.
I have a family account, so I have 6 users. But so that when I play the canteens and stuff, they'll quit messing up my Spotify. My Spotify thinks I like terrible music.
Wow.
That was an extreme roast, Mr. Hunt.
Yeah, because the music I have to play at canteens is, well, some of it I like. I will say that. So if working with the rectangles that we have, what's the first split we're going to make here, Molly?
so what I did was the 1/3 first.
Ooh, Molly did the thirds first, which we really can. We could do either that we want. So a third of 8 is like a little over 2, I think. A little over 2. Yeah, that's close. Okay, so then what do I shade?
You shade.
And then the other split we had for Joe, 50% of the garden is carnations. Now, if we're being particular, we would actually follow the order of the problem and do the 50% first. Just if we're being particular, and here's why. The end question wants to know what part of the garden is red carnations. So right now my blue indicates carnations, and my red indicates red, but blue and red are the red carnations, right? So how much of the garden is red carnations? Well, what's the garden split up into now? 6. So how much is red carnations? 1. And that is, if we did 1/2 times, 1/3, that's 1/6, which makes perfect sense. I would show out the math too, not just the rectangle, to help your brain realize that, oh, okay, that's why it makes sense. Fraction multiplication is continually splitting. Now, if we have 3 fractions, we can't really show that very easily. It gets real hard. Because then, if they said 1/2 of the red carnations got sick, right? That, for me to draw, like plants get sick. I have to go to the red carnations, box out that box, and split that in half. And now I would actually, no, you don't have to do this. Now I would actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spots. If I think about them, this gets really difficult. So any more than 2 fractions is kind of hard to draw, but 2 fractions we can draw really easily. Questions? You weren't asleep. If you were, I would have let gravity wake you up. I was chatting with a kid at the track meet last night, and or at the cross country meet. Sorry, I know people get particular. He was like, "Do kids fall asleep in your class?" I was like, "If I do, they wake up." And he's like, "What do you mean?" I'm like, "I wake them up." Well, really, gravity wakes them up. He's like, "What? You fall asleep in my class, I just lift your desk." I don't wake you up. Gravity wakes you up. All right, so. I can lift that. How do you think it got there?
No, but then there's 2 other kids.
Tell them to lift their arms.
All
right.
We're not on the.
So because we're now pros at this, and we know that this shows 1/2 of 3/4, right? Like our beginning problem. We're going to do a few of these. So if 3/8 of the students, sorry, I think this is actually multiple choice. No, this is the problem with planning 3 classes. I forget which this problem was. Oh yeah, write a problem that goes with it. So they have example statements up here, right? We could make other situations that match this. So 1/2 of the parking lots is trucks. 1/4 are white. What would be the resulting answer and thing that goes with it? You know, I know I described this weird. So all right, refocus, reset. Ignore everything I just said.
Okay.
I'm going to make this easy because I want to wrap real quick. If these are the problems put in front of us, what is the resulting fraction and what is it describing? So if Mr. Hudson called on Micah, right, me, 1/2 of the parking lot is trucks, 1/4 are white. What's 1/2 of 1/4? Well, that's an 1/8, and what we're describing is white trucks. So we're saying an 1/8 of the lot is white trucks. So Meredith, are you able to do that for B? Correct. No, C, because I don't know why B is the same. Oh, it's just drawn differently.
Let's see.
What portion do we end up with double shaded? 2 thirds and thirds. Yeah, 2 ninths. So then 2 ninths of so 2/3 of the classes are boys. So they're talking about classes, right? First they're talking about classes. So 2 ninths of the classes are boys wearing basketball shorts, right? So we have to put everything together. So classes, boys, basketball shorts, all that. So we just have to take both statements. This is kind of a weird problem saying take both statements when you're making your answer. So if 1/3 of the menu is low fat and 5/8 are salads, like low-fat salads, then how much of the menu is low-fat only salads? It's this section. These are low-fat options that are not salads, right? So they meet the low-fat, but they don't meet the salad. So then this is actually 5. It's not 5/8. Their statement here is wrong. That's what they're trying to get us to identify too. It's 5 out of, well, a total 8, 16, 24. This is 5/24 are low-fat salads. I don't love that problem, but I think that is the last one. Yeah. So just make sure that when you're looking at the division of the boxes, you take both statements with you. Right? Oh, shoes. My bad. Yeah. So if we look at anything from your homework that might be a trapdoor, you have this math notes box in your book if you need. But yeah, we don't even get too far into this right now. 90 and 91 are about that. So, all right, have a wonderful day, guys. Wait for the wall to open. We'll get you over there.